Hello, ladies and gentlemen, and welcome to the notes on rational functions, slant asymptotes, and holes. Up to this point, um, you should be able to find vertical asymptotes and horizontal asymptotes and graphs that have those things. Well, what if they have slant asymptote and holes? What do they look like? So that's what we're about to investigate now. I will tell you, though, it is challenging because slant asymptote and holes come from equations that look very similar. So for instance, look at this equation we have in front of us, y equals x squared plus 6x plus 8 over x plus 4. That looks very similar to something that has a hole or slant. Now, by looking at it, we can't tell. We actually have to do some things to find out whether or not it has a hole or a slant asymptote. So, to do this, ladies and gentlemen, what we're going to ask ourselves is, can the numerator be factored? Well, actually, first, what we need to look at is the exponent in the numerator and look at the exponent in the denominator. Now, the exponent in the numerator is x squared, or 2, right? The exponent in the denominator is a 1. So the exponent actually is bigger in the numerator. This would indicate to us, ladies and gentlemen, automatically that there is no horizontal asymptote. Since there's no horizontal asymptote, it means one of two things. There has to be a slant asymptote, or there has to be a hole somewhere. Well, to figure out which one it is, we have to see whether or not the numerator can be factored. And if we look at the numerator, it's 1 times 8, which is 8. And the factors of 8 are 1 and 8, 2 and 4. Which one of these pairs would add up to 6? Yep, 2 and 4. So, ladies and gentlemen, this thing can be factored. And the way we're going to factor this is y equals x squared plus 2x plus 4x plus 8. And all this is going to be over x plus 4. Now, once we have the factors and we've rewritten it this way, we now have to ask ourselves, well, what do the first two terms have in common? Like, for instance, what does x squared and 2x have in common? It turns out, ladies and gentlemen, that x and 2x have an x in common. And if you factor out an x from x squared, you get an x. If you factor out an x from 2x, you get plus 2. Now that's the first half. The second half, ladies and gentlemen, you see the 4x plus 8. What can these have in common? If you say 4, you're correct. And I always don't leave myself enough room, so let me rewrite this real quick. Sorry about that. I always try to give myself enough room to write stuff, and I don't. So we had x plus 2, and we're factoring out a 4. That looks so ugly. And we're going to be left with x plus 2. So we'll have x plus 2 after we factor out that 4. And if you look at the bottom, we have x plus 4. Okay, well, so far we know it factors. And what we're going to write here is there's an x plus 2 that's common in both. So we're taking out an x plus 2. And we're left with x plus 4 in the numerator and an x plus 4 in the denominator. Ladies and gentlemen, when this happens and you have an x plus 4 and an x plus 4 in the numerator and the denominator, they will cancel each other out to be 1. And so what we're left with is x plus 2. Now, what does this mean? Well, this graph is actually just a straight line with a slope of 1 over 1 and a y-intercept of 2. So we would go to our graph and we'd plot this line. We're going to go up 2, plot a point, and then go up 1 to the right 1. Oops, missed it. We go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, and just keep doing that until we're like, okay, I get the idea. Now, be really careful because when these things canceled, that means we had a hole. We had a, oh, that means we have a hole. And this hole is going to occur wherever x plus 4 equals 0. And well, where does x plus 4 equal 0? X plus 4 equals 0 at negative 4. So when we draw this line, okay, when we draw this line, when we get to x equals negative 4, we're going to put a hole in the graph. Okay, it's a straight line, but it has a hole in it. So what does this look like? Let's see. I'm going to go ahead and grab our line maker here. And I'm going to start drawing a line like this. When I got to be really careful because when I get to x equals negative 4, I'm going to stop. Okay, and then I'm going to continue this straight line. And what I'm going to do is right here at x equals, oops, and that should be, oops, don't take off the whole thing. I just wanted to take off that hole. Thank you. I just want to put a hole here at negative 4. And that's how we draw a hole at negative 4. It's a straight line with a hole in it. Say, but that's not what rational functions look like. Well, not all rational functions have asymptotes. Some have holes in them. So this would be another thing that we're going to have to actually consider. And I will tell you, for the most part, any graph with a hole in it, it's going to follow very simple, similar procedures. All right, let's try another graph. Let's go look at another equation real quick. Again, feel free to rewind or pause the video if you need to. Looking at this one right here, ladies and gentlemen, we see that x squared minus 5x minus 14 over x plus 2. And looking at it, I can't tell whether or not, what's going on. I do notice that the exponent in the numerator is bigger than the exponent in the denominator. So automatically right now, I could write down, hey, there's no ha. There's no ha. There might be a hole. There might be a slant asymptote. To figure this out, we need to factor the top. So in other words, let's get the factors of negative 14. That's going to be 1 and negative 14. Negative 1 and positive 14, 2 and negative 7, and negative 2 and positive 7. Now, which of these combinations will add up to negative 5? If you said 2 and negative 7, you'd be absolutely correct. So that's how we're going to factor this thing. We're going to say y equals x squared plus 2x minus 7x minus 14. All this is going to be over x plus 2. Okay? Now let me get rid of this stuff over here. We know there's no horizontal asymptote. We're not sure if there's a hole or if there's a slant asymptote, so we're just going to go ahead and complete this factoring here. Let me give myself some room here before I run out. And here we go. What's common in x squared and 2x? Well, that would be x squared. I'm sorry, that would just be x. And when we take out an x from x squared, we're left with x. When we take out an x from 2x, we're going to be left with plus 2. Now, what does negative 7x and negative 14 have in common? If you said negative 7, you'd be correct. When you take out a negative 7 from negative 7x, you're left with x. And if you take out a negative 7 from negative 14, you'll be left with positive 2. And notice we have x plus 2 in both of these terms, and x plus 2 in the denominator. When we finish factoring this, ladies and gentlemen, we're going to be left with x plus 2 times x minus 7 over x plus 2. And look what happens. These x plus 2's are going to cancel each other out. That means that there will be a hole at x equals, set that equal to 0, and you get -2. So when we get to -2, whatever this graph looks like, we got to put a hole in it. So turns out that this graph is x minus 7, which is just a straight line with a slope of 1/1 and a y-intercept of -7. So let's go over here, ladies and gentlemen. Let's go to 1, 2, 3, 4, 5, 6, 7. Let's put our dot. All right. Then we go up 1 to the right one, 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 up 1 to the right one. Okay, and once you get comfortable with that, you say, okay, it's going to be this line right here. But when I get to -2, I need to stop. I can continue my line. Okay. And then come back over here and put our hole there. Because at -2, it's going to have a hole. It's a straight line with a hole in it. And most of these are going to be like that, ladies and gentlemen. I'll show you one in class that actually is not a straight line, but the procedure is the same. All right. Let's go ahead and continue with our next example, ladies and gentlemen. Please write this one down. And again, rewind the video, pause it if you need to. So we look at the numerator, we look at the denominator, and once again, we realize that there is no horizontal asymptote. No horizontal asymptote. Not sure what happened there. We have no horizontal asymptote. So there might be a hole, there might be a slant. Let's see if the numerator can be factored. Turns out that the factors of -6, because 1 times -6 is going to give us -6, is going to be 1 and -6, -1 and 6, 2 and -3, and -2 and +3. Which of these will give us +1 for the middle? If you said -2 and 3, you are correct. Now, ladies and gentlemen, I'm going to go ahead and skip the whole factoring part stuff. Hopefully, you can get some practice doing that, and we'll do more practice in the classroom. This actually factors out to x minus 2, x plus 3. And this is going to be over x. Does anything cancel out? Nothing cancels out, ladies and gentlemen, because we just have an x in the bottom. We don't have an x minus 2 in the denominator or an x plus 3 in the denominator. So this indicates that there is no hole. There has to be a slant asymptote. A slant asymptote. So how do we find these slant asymptotes? Well, let me back out of this real quick, and I will show you how we'll get this slant asymptote. All right, and again, sometimes we have to factor it because, again, there's no way of just looking at it unless you're making up the question, and I'm the only one making up the question, to tell whether or not it's going to have a slant asymptote or not, or a hole. No-ha. All right, so to figure this out, ladies and gentlemen, we're going to take the denominator, put it in the outside of this division sign, and we're going to do some long division. One of the reasons why we practiced long division before we did this rational functions unit. X goes into x squared, x times x is x squared. We're subtracting that. Drop down the x. How many times does x go into x? 1 time. That's a plus sign. 1 times x is x. Subtract that. We drop down the -6. This is our remainder, so we're going to write the remainder -6 over x. Now, ladies and gentlemen, our slant asymptote is going to be y equals x plus 1. Say, well, what about the remainder? Well, we're going to find out that the remainder actually just goes away. it goes to 0 when x gets really big. And I'll show you that in class so that we can know why the remainder just disappears. But for right now, the remainder just disappears. What I want to do is I'm going to draw this slant asymptote. So I'm going to go to my graph and I'm going to draw this slant asymptote. It has a y-intercept of 1. Okay, oops, I missed it. Oops. Okay, and then it's going to go up 1 to the right 1. So up 1 to the right 1, 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 the slope of 1. Oops, that one. Now, when I do the slant asymptote, ladies and gentlemen, make sure when you draw it that you draw it with a dashed line. Okay, we want to make sure that this thing has a dashed line. Okay. Now, there's one thing we know that has no horizontal asymptote. We know it has a slant asymptote, but this also has a vertical asymptote. And to find vertical asymptotes, set the denominator equal to 0. And look at that. With this denominator equal to 0, the y-axis is our vertical asymptote. So this graph is going to look like, it's going to be here, it's going to be here, it's going to be here, or it's going to be here. It's going to be two of these pieces right here. So what I have to do is plot a point. All right, so let me go ahead and I'm gonna shrink this part here so I can have some more room to draw here. Okay, now let's plug in some points, and I say plug in some nice x values. So our x-intercept, our vertical asymptote is 0, so I'm gonna pick a point to the left of 0 and to the right of 0. I'm going to pick x equals -1, and I'm going to plug it into this formula here. So I'm going to get y equals -1 squared plus a -1 minus 6. And all that's going to be over -1. I like to put the -1s in parentheses because weird things happen when you don't. So turns out that y is going to be 1 minus 1 minus 6 over -1. This, ladies and gentlemen, is just going to be -6 over 1, or -1, which is just positive 6. So one of the points you should plot would be -1, positive 6. And that, ladies and gentlemen, is going to be way up here like there. So that means this is our first piece of our graph. Since this is the first piece of our graph, okay, what we're going to do now is we're going to take off this piece. So this piece down here, I'm going to get rid of it. Oops. This one, I'm just going to erase it. Okay, so this piece and that piece can't exist together. All right, now let's plot a point here. And I want you to guess, which one do you think it's going to be? Okay, well, let's go ahead and I'm going to select this part here. All right. Now, ladies and gentlemen, I'm going to go ahead and pick x equals 1 because that's on the right side of 0, our vertical asymptote. Here we go. 1 squared plus 1 minus 6 over 1. Notice I don't put 1 in parentheses because nothing weird happens when you don't put a 1 in parentheses. Weird things happen with negatives. Alright, 1 squared is 1 plus 1 minus 6 over 1. 1 plus 1 is 2. 2 minus 6 is -4 over 1. And this point that we're going to plot is going to be 1 comma -4. So 1 comma -4, ladies and gentlemen, is right here. So that means we're going to use this piece. Did you guess the right piece? And Sometimes it's the one on top, but this time it's the one on the bottom. Since we're doing this graph right there, we need to get rid of this piece right here. And that's what our graph is going to look like with a slant asymptote. Okay? Kind of weird. I know. You got to plot some points, just like we did with the vertical and horizontal asymptote graphs. All right.